Hey everyone, this is Ken. We're going to do a few more properties of the definite integral. So first thing I want to say is that up to this point, the integral has been defined on an interval from a to b where a is less than or equal to b. But what if you wanted to define the integral from b to a where a is less than b, f of x dx? Well, one thing you could do is you could just say there is no definition for that. What are you talking about? You have to do it from a to b. But what we do instead, it's just become easier over the years to make the following definition, to say, look, whenever you've got an integral and the bounds are switched like that, you can reset them to go from a to b, but then just sneak in a negative sign. This is actually the definition of integral from a to b. And if you want, you can think about it sort of like in terms of an orientation, like here your number line is, or here your number line is sort of oriented the opposite way from right to left instead of left to right. And you can correct that orientation by putting in a minus sign. It actually makes lots of our calculations later on work out pretty easy. So if you take this as just a part of the definition of definite integral, then you can quickly get a nice consequence. So for instance, if I take any function and I ask you, what's the integral from a to a of f of x dx? Then you're going to say, well, I can figure this out because if I switch the bounds, I'll end up with a negative sign. So I switch the two bounds, but since it's a to a on top and the bottom, the integral doesn't change, but I still get a negative sign. So there's one and only one number that's equal to its own negative, and that's 0. So this is consistent with something that we already knew. Integral from a to a should be the area of the vertical line under the curve. But since that line has no area, you'd expect it to be 0. So this definition is certainly consistent with that. Another property of integration that I want to show you is what happens if I take a function, say, I'll draw out the picture here. I take a function, and here's a and b, and say I've got another number c out here. And then if I take the integral from a to c of f of x, it's y equals f of x. Knowing that this is just going to be the area under the curve, certainly that should be equal to integral from a to b, it's the area for this part, plus integral from b to c. So in other words, if you split up your domain by one point, then the area under the curve is going to be just the sum of the two areas. And this actually works even when you're not just starting with a to c. So for instance, like what if I wanted to start with integral from a to b, f of x dx? So that's just like the area in the first part there. And it's still true that this is equal to the integral from a to c, f of x dx, plus what? Well, I go from a to c, and then I go from c to b, right? Because that's how the rule works. You take 2 points, and then you have another point, whether it's between them or not, and you go from your initial point to that one, and then that one to the next one. And so why is this equality true? Because if you look back at the picture, you're starting out with a to b, so this chunk of area, and that's equal to what? Well, it's equal to integral from a to c, so the larger chunk, but now I have to subtract this part in order to make it work out. So what do? Well, if I take the integral from c to b, by definition, that's the negative. This is the negative of the integral from b to c. So I'm actually subtracting off exactly the right amount to just give me integral from a to b. So a lot of times when you hear this rule explained, you'll hear people say, well, you go from one point to the other and you need to take a point in between them. But it's actually not true. You can take a point anywhere you want and then just go from one limit to the other one and then split it up like this, from like a to c, c to b, whether or not c is between a and b or not. And the reason why that works out so nicely is because of that definition that I just wrote down. The way we define definite integrals, if you switch the bound, it picks up a negative sign. So that just makes these formulas that we like to use really consistent and easy to work with.